Hello guys, welcome back. So in the previous lecture, we have seen how we can print a singly linked list. In case if we are reversing it, then we have to find a way to see that list clearly, right? In an efficient way, right? So that is what we have done in the previous lecture. If you haven't watched, then please go and watch that out. And if you don't want to watch, then that's completely optional, because see, that function we have implemented just to see easily whether our list got reversed or not. Okay, so that is what we have implemented in the previous lecture. So now let's quickly implement the reverse method in this lecture. Okay, so yeah, so I'll write a function reverse. Okay, so here what I will do, I will first take few variables, right? So let's say current node. This one I will start with this dot head. Okay, now what we have to do first is we have to swap the head node from the tail node and then tail node from the head node, right? Because we have to reverse the linked list, right? So that means the head is going to be the tail and tail is going to be the new head, right? So let's do that thing first. So this dot head equals to this dot tail, and then this dot tail equals to this dot head. Okay, so here we have done the swapping, like we have made the head as a new tail and then we have made tail as a new head. I think so far so good, right? So now we need two more variables in order to reverse the middle nodes, right? The nodes which are in between. Okay, so for that I will take let previous as null, and then the other one I will take as next. Okay, because this is the one. See, what we are going to do now is we are going to pick the current node, we are going to make its next node as its previous node, and then its previous node as its next node. Okay, if it is sound confusing, I'm repeating it once more. We are going to pick a current node, so it will have the previous node and next node, right? So what we are going to do, we are going to make its previous node as its next node, and then we are going to make its next node as its previous node. So we are basically switching the places of the nodes which are around that current node. Okay, that is what we are going to do. So for that, what we have to do is we have to use a while loop, and in case if you want to use for loop, then that's also fine. That's up to your personal preference. So I find this one a little bit cleaner, so that's why I'm using it. Okay, so we are going to run this loop until we are finding the current node. Okay, and then at the end we are simply going to return the complete list from this. Okay, so far so good, right? We have a while loop, and then inside this while loop the actual logic comes in. Okay, so here what we have to do now is, see, we are already getting the current node. Okay, now what we have to do is we simply have to pick the next node. Okay, let me quickly write it down instead of telling you all these things. So what we are going to do is current node dot next. Okay, that means we are simply moving the next node from the current node to current node's next node. Okay, so that is what we have done so far. Okay, we have current node, we will already have the current nodes dot next value. We are simply storing that current node dot next value as the next node. Okay, and then in the next step what we have to do, current node dot next, we have to store the previous. Okay, so right now previous is null, and that is what we want actually, right? So let's say if it is a first node, okay, then its previous we have to set it as null, because that first node is going to be the new tail node, right? And tail will always have null as the next node, right? So that is why it is called tail node, right? So since we are going to make the first node as a tail node, then the previous will be null. Okay, now it's time to update the previous. So in previous, what we are going to do, we are going to store the current node. Okay, that means we are simply moving forward in the linked list. Okay, so current node we are going to make the previous node. Okay, and then in the current node we are going to store the next node, right? Oh sorry, that means we are moving forward here in this step. We are picking a current node, we are updating all the things, and then we are making the current node dot next as the current node. That means we are moving forward in the linked list. Okay, so that is what we are doing here. Okay, so let's first test it whether it is working fine or not. Then I will explain you like whether it is like how it is working, right? In case if you didn't understood. Okay, so now let's first see new SLL. Okay, or let's use that display method. Why I'm writing this display list. Okay, so here if you see the sequence of the linked list is high, high 2, high 3, high 4, right? That means it's the original sequence. As you can see here, our linked list was like this: high, high 2, high 3, high 4, right? Now let's quickly reverse it and then let's see what happens. Okay, so I am going to reverse it. Now everything looks fine only. I'm not going to expand this because we are going to use this existing method which we have created in the previous lecture. Okay, as you can see, our list totally got reversed, right? That means high, high 2, high 3, high 4, high 3, high 2, high 1. That means our list totally got reversed, right? So that means our reverse method is working totally fine here. Now let me take you through this this logic what I have written here. Okay, so let me basically pick this thing. Where is that linked list example I was trying to search? Okay, so here we have it, right? Okay, so let me write it down here. Okay, so here what we have done, this was the head node. We made this as the new tail. Okay, new tail, and then this one we made as a new head, right? Let's comment out this thing as well. Okay, so let me quickly remove the autosave because it's keep on loading because of this, right? Okay, so now let's move to the new part. Okay, so let's say we have picked the current node as the head node. Okay, now what we are doing, the next node we are storing as current node dot next. That means here it is going to be, next node is going to be node 2. Okay, according to this one, the next node is going to be node 2, right? Now current node dot next, current node, we have the current node like this, right? Or let me quickly copy and paste it here so you guys will see clearly which one is the current node. Current node, right? So our current node, let's say we have the head node. Okay, now the next node is going to be node 2, right, which we are storing in the next variable. Okay, and then current node dot next, that means head dot next is going to be node 2, right? So in node 2 we are going to store null. Okay, sorry, previous. So current node dot next, here right now it was node 2, right? So now instead of node 2 we are going to store as null in head node, right? Because this is our dot next. So this is going to be the next value. Right now previous is null, right? That means current node dot next we are going to store as null. Okay, because we are going to make this node as a tail node, right? That is why it is null at initial stage, right? So now previous, so previous is going to be current node. So right now the current node was head node, right? Right. So since current node is head, we are going to make this as previous node. Okay, so previous node, current nodes dot next was previous, and then previous node is going to be current node. That means we are simply updating the value of the previous node. Okay, now here, okay, current node. So we are now moving forward in the linked list. So right now our current node is this. We have updated is its next as null. Okay, and then its previous as what was that? This particular node, right? Yeah, so its previous we have updated as this particular node. right? Now we have to move forward in the linked list, right? So that's why we are simply updating the current node. So current node dot next is going to be our new current node. Okay, so now the current node dot next is node 2, right? As you can see here. So this is what we are going to store as the current node, and then the cycle will keep on running. Okay, so this is how like the reverse method works in the linked list. Okay, so if you want, you can use the for loop as well. So for loop will work like this. Let me show you that an example of that as well. Okay, I'll simply comment it out. So it will be for let I equals to 0, I is smaller than this dot length, and then I plus plus. Since we are keeping track of the length, so it's easy for us to run a for loop as well. So this block will go inside the for loop in case if you want to run it in for loop, but this one I found a little bit cleaner, so that's why I used it. Okay, so yeah, this is how the reverse method works in the linked list, right? In the singly linked list. I hope you understood. Like if you didn't understood, then you can again like rewatch the video to make sure you understood it completely, because this is one of the important thing, or it is one of the mostly asked questions in the interviews, as I've already mentioned in one of the previous lectures, right? So now we are done with the linked list. All there is left in this data structure is time complexity and space complexity. So let's quickly see that in the next lecture, and then I will give you the final code snippet of singly linked list in the next lecture. Okay, so I'll attach it in the description in the next lecture. Okay, so for now all you need to do is you just need to practice this method, and obviously if you practice twice or thrice, then you will be perfect in this and you will get the complete idea like how it is working, right? And then display list, if you haven't watched the previous lecture, then you can quickly take a screenshot from here. Okay, and this is all about reverse method. So this is it for today's video. See you in the next one.